Today we will discuss about ninth topic is a resting and action potential. So what do you mean by the resting and action potentials? Now any kind of the cell membrane, for example, a red blood cell. So this is your RPC, red blood cell. Now outside of the cell membrane as well as inside of the cell membrane. Now in this case, this cell membrane which will allow some substances to pass through it membrane, whereas other are not allowed to pass through the cell membrane. Okay, now first we will briefly discuss about resting potential. After that we will brief discussion about the action potential. Now we will discuss about the first one is resting potential. Okay, from this resting potential, the cells of the body are surrounded by a body fluids. Now this cells, each and every cell, body fluids are surrounded, which are in a conductive solutions contain charged atoms, ions, and prominent ions are sodium Na plus ions. Now these are the Na plus ions, potassium K plus ions, and chloride Cl minus ions. The membrane of the cell allow entry of the potassium and chloride ions, whereas blocks the entry of the sodium ions. Various ions seeks a balance between the inside of the cell membrane and outside. The sodium is unable to penetrate the membrane. This resultant in unbalance of the ions concentration and electric charge. Now, this unbalanced condition, normal condition, so that is, if general cases, what happen, a nerve or muscle cell. So now this is your basic nerve, N represented, I am muscle cell is a M represented here. Nerve and muscle cells are encased in a semipermeable membrane. Sodium ions, Na plus ions, are unable to penetrate. So now these Na plus ions are unable to penetrate the inside of the cell membrane. Now what is the basic definition of this? What is the basic definition of the resting potential? So equilibrium is achieved with the potential difference across the membrane. The inside of the cell is a negative and outside is a positive. So inside is a negative, so that is your Cl minus. So inside is a negative Cl minus and outside is a positive, so that is your Na plus ions. So these two are in the equilibrium condition. Okay, then this membrane potential is called as a resting potential. Okay, this potential maintained until some kind of disturbance is caused by upset the equilibrium. The resting potential range in generally, so general, the resting potential range is minus 60 to minus 100 millivolts, minus 100 millivolts. So from this figure, okay, this is an inside Cl minus and K plus ions are equal to the outside cell membrane Na plus ions. This is your equilibrium condition. Then the generated potential is called as a resting potential. Now we will move into the action potential. So what second one is, go for the action potential. From this action potential, if you are applying any excitation, for example I am applying some external force in this direction. Now in this direction I am applying some pressure P. Okay, this is your external excitation. The excitation of a section of a cell can be by using the flow of ionic current or any external applied energy. This excitation of the section of the cell causes change in the characteristics of the membrane, which allows some of the sodium ions to enter. The movement of the sodium ions into the cell further accelerate any of the sodium ions. This leads to rush of the sodium ions inside the cell. Now all the Na plus ions are entered into the inside of the cell membrane. Inside, Na plus ions are very rusted. Now, whereas potassium ions are try to get outside, are unable to out that fast. Now these are unable to out that fast. Net result is slightly higher potential inside. So that is your net. So it is very higher potential. The cell. This cell potential is known as a action potential, which can be general ranges. So then action potential general ranges plus 20 millivolts from this circuit. So from this one is a plus 20 millivolts. In other words, the which cell is excited gets depolarized and leads to action potential. The process of changing from resting state to action potential is called as a depolarization. Now this is representing as a resting and action potential.